Welcome to our third lesson on arithmetic sequences. In this video, we are going to be looking at writing general rules or general expressions, explicit rules for our arithmetic sequences. So the general term an is given by a1 plus d times n minus 1. So a1 is our first term. D is our common difference. And n is our variable. Now you might be asking yourself, if we're writing this as an equation, why are we using n instead of x? And what type of function would this be if we were using x instead of n? And so pause for a moment if you want to think through this individually. But the reason why we're using n is because our inputs are only integers. We can't plug in 1/2. We can't plug in 0. We can't plug in -1. So I should be even more precise and not just say our inputs are integers, but whole numbers, 1, 2, 3, 4, and so on. So if we were using this x for any number rather than any whole number, we would have a linear equation. So we want to find a formula for the general term. So just as a reminder, we're going to use an is equal to our first term plus our common difference times n minus 1. And so if we look at this first example, we have 1 plus 2, 3 plus 2, 5 plus 2, and then 7 plus 2. So our common difference, d, is equal to 2, and our first term, a1, well, it's up here, a1 is equal to 1. So plugging this into our formula, we have an is equal to 1 plus 2 times n minus 1. Now you could leave it here, but if we want to write our expression more concisely, we can distribute and simplify. So I'll have 1 plus 2 times n minus 2, because we're distributing this 2 to both terms. Combining like terms, we have 2n minus 1. So notice that what we've written now is very similar to our slope-intercept form of a linear equation. So we can see even more explicitly now that these are types of linear functions. They just happen to only be defined for whole numbers, 1, 2, 3, 4, 5, and so on. Our next example is a little bit harder to see. So I'm going to do 9, 6 minus 7, 6. And this gives me 2 over 6, or 1/3. Then 7, 6 minus 5, 6. This once more gives me 2, 6, or 1/3. 1/3. And so if I add 1/2 plus 1/3, do I get 5, 6? Well, I need to write a common denominator, so I can multiply by 3 over 3 on the left to get 3 over 6, and then 2 over 2 on the right to get 2 over 6, and that does in fact give me 5 over 6. So our common difference, d, is 1/3. So our equation is going to be our first term, 1/2, plus 1/3 times n minus 1. And so I'm going to again simplify. So we have 1/2 plus 1/3 n minus 1/3. I need to rewrite these as a common denominator. So we'll have 3 over 6 and 2 over 6 like we did over here on the left. And so an fully simplified is going to be 1/3 n plus 1/6. And so this would be our explicit rule written in slope-intercept form. Our last example on this slide, we're subtracting 4, then we're subtracting 4 again, and we can see that again we're subtracting 4 and subtracting 4 to get our sequence. So d equals -4. Notice that our first term is 0. So when I write our equation, an equals 0 minus 4 times n minus 1. When I simplify this term I don't need to write, it's just 0. So I can write it as -4 times n plus 4. Because when I distribute this -4, the -1 changes signs. So an observation from this example is that we have a negative common difference. And so we can think this is 0 plus -4, -4 plus -4, -8 plus -4. So even though we have this negative number, the operation is still fundamentally addition. So that about wraps it up for this video. In the next video, we're going to be looking at finding an explicit rule for arithmetic sequences when we don't necessarily have the list of numbers, we just have more limited information.